All right, today we're going to start graphing. Okay, so first thing we have to talk about is how do you tell if something is a solution to an equation? Okay, so what you're going to do is you're going to take the x and y values, plug them into the equation, and check that both sides of the equal sign are the same. Okay, so just a reminder, x, y, x always comes first just like it does in the alphabet. So you're going to take 2 times 3, because that's your y value, plus -2. We're going to figure out if that actually does equal 4. So 2 times 3 is 6. 6 plus -2 is 4. Okay, so this point is a solution to that equation. Okay, so then doing the next one, same thing. Here's your x and your y. So you got -1. Okay, be very careful with that extra negative out in front. Plus 2 times 4, does that equal 8? That's what we're trying to figure out. So 2 negatives, remember, make a positive. So 1 plus 2 times 4 is 8. So this time I get 9 equals 8. So this would be a no. This point is not a solution to that equation. Okay, so then we're going to get into graphing a little bit more. Okay, so you're graphing the following equation. Okay, it doesn't give you any values, so the 5 values I want you to use are -2, -1, 0, 1, and 2. Unless it gives you values like it has previously, those are the 5 values I want you to use. Okay. So I'm going to take these, plug them in, and solve for y. So you got -2 times -2 plus y equals -3. So -2 times -2 is 4, plus y equals -3. Solve to get y by itself, so subtract 4 from both sides. Y equals -7. Okay. Then you're going to go through and do all the rest of them. Okay, so -2 times -1 is 2. If you're going to subtract that over, you get -5. 0, you get -3. Now, some of you might notice the pattern already. So then this will give you -1, and this will give you 1. Take your points and plot them. So -2, 2, 3, 4, 5, 6, 7. -2, -7. -1, -5. 0, -3, 1, -1, 2, 1. Okay, now before, when we had a restricted domain, okay, where it actually gave us the domain values, we didn't connect our points. Okay, now we are going to connect our points. Okay, not grading you on the perfectness of your straight lines. Okay, I'm more worried about, do you have the right values and did you plot the correct points? Let's do another one. Okay. So same thing. Use those 5 values. So 2 times -2 plus y equals 2. So -4 plus y equals 2. Add the 4 over. Y equals 6. So 2 times -1 is -2. Add the -2 over, you're going to get y equals 4. Two times 0 is 0, so you get 2. Again, you probably notice a pattern. We're going down 2 each time. So you get 0 here and -2 there. Okay, if you don't see the pattern, it's okay. Just focus on plugging in your values, solving for your y value. So -2, 6, -1, 4, 0, 2, 1, 0, 2, -2. And then again, connect your points. Again, not grading you on the perfectness of your drawings. That's okay. I'm looking for the correct points in the correct spot and the correct numbers up here. Okay, last thing we're going to talk about is vertical and horizontal lines. Okay, so vertical lines, we've talked about the vertical line test. So vertical lines go up and down. Okay, when you look at an equation and you're going to graph a vertical line, it's x equals a number. Okay, and we'll talk about why that is in just a second. Horizontal then, go left and right, and it's y equals a number. Okay. So, on the next slide, we're going to do x equals 2. So where on my graph does x equal 2? So if I look at that, that's this spot right there. Okay, well if I would draw a horizontal line through that, I'd just be on the x-axis. Well, that doesn't really work. Okay, so that one is why these are vertical lines. Okay, it goes against everything that you're used to, because you're always thinking x is left and right. Okay. The value itself is left and right, but the vertical line is actually up and down. So y equals -3 would be right down here, and it's a horizontal line through that point. Okay, so that's the y equals -3. That is the x equals 2.